6.3 exercise. We continue with the question number here 13. So there the curve is x square by 9 plus y square by 16 equals to 1. We know that this is the ellipse where b is greater than a. Here a square is 9 and b square is 16. So a is 3 and b is 4. So this is the ellipse whose measure axis is along y-axis. So it would look like this here, you know, from 11th standard. B is bigger than A. This is 9, so this will be 3. You know, this is 3, 0, minus 3, 0. The 16, so here 0, 4 and 0, minus 4. These are called vertices. Now from this you can answer both the questions parallel to x-axis. You want tangents parallel to x-axis. So here tangents parallel to x-axis are this. One tangent is this, which is parallel to x-axis. This one. And the other one is this. Right? These are the two tangents parallel to x-axis. So here equations of tangents, in this case equations of tangents would be horizontal line. What's the equation of the horizontal line? Y equals to constant. So y equals to 4 or y equals to minus 4. That is y equals to plus or minus 4 equals to 0. One is this. And what about the other one? Equations of tangents in the second sub questions here. Parallel to which axis now? Parallel to y-axis. So you have one tangent here. This is one tangent parallel to y-axis and this is one more tangent. Their vertical line, so x equals to 3 or x equals to minus 3. So therefore x equals to plus or minus 3 equals to 0. These are the two, tangents parallel to here y-axis. Y-axis means which lines? Here you have tangents parallel to in the second sub question. Parallel to y-axis means these are the vertical lines. And if you have vertical lines, you have this equation. These are the horizontal lines. Point of contact are this 3, 0, minus 3, 0. I just wrote by diagram. Alternatively, you can do like this. What you need to do? First, you need to get this point of contact. So in the first sub question, tangent is parallel to which axis here? X-axis. So in the first question, you are given indirectly dy by dx equals to 0. Use this and you will notice that at the end you will get this. This much for you. Try this. Right? This is for you. Exercise. We did number of times such things in earlier sessions. Okay. And what about the second question? Their tangent is parallel to y-axis. So dy by dx is undefined. So 1 upon dy by dx will be use this equals to 0. So again you will get the point of contacts. And which point of contact? That is this and this. Oh sorry, parallel to y-axis, so we'll get this. Sorry, here parallel to y-axis. So in the first question, parallel to x-axis. So here you will get, 0, 4 and 0, minus 4. And here parallel to y-axis, so you'll get these two point of contact, 3, 0 or minus 3, 0. Try it. This is for you. This is little correction. That was my mistake. Please correct it. This is 0, 4 or 0, minus 4. Because you want tangent parallel to which axis? X-axis. So these two tangents. So this two will be point of contact. And parallel to y-axis, then these two will be point of contact. Just use this parallel to y-axis. So slope is undefined. Slope of tangent. So 1 upon dy by dx will be 0. So I'll get this point. This I did directly. Question number 14. Find equations of tangent and normal to the given curves at the indicated points. Okay, so all are similar questions. I'll go to third question directly. There the curve is y equals to x cube. Your point of contact you are given 1 comma 1. This is the point where you want to draw the tangent. So this is your indirectly x0 y0. In earlier questions we were finding this here already given to you. Just what you need to get the slope. That's the slope of tangent dy by dx, which is 3x squared. And you want it 1 comma 1. So put x equals to here 1. So this is 3. And what is this 3? This is nothing but the slope of tangent. And therefore the slope of the normal will be minus 1 upon 3. So therefore equation of tangent, what's the equation of the tangent? It is point slope form. Y minus y1, that is 1, slope into x minus x1 x0, which is also 1. So what we'll get from this? 3x, I'll take y on the other side, so minus y. This is minus 3 plus 1, so you have minus 2 equals to 0. Slope of equation of the tangent. Now we'll get the equation of the normal here. So for that just you need to, point of contact will be same, equation of normal here. Just slope would be reciprocal with opposite sign. Y minus y1, instead of this here it would be minus 1 upon 3, minus 1 upon 3 into x minus 1. So we'll get the 3y minus 3. You know, slope of the normal is 1 upon f dash x0, if you remember. We have used this. Okay. So minus x plus 1. So what we'll get? X plus 3y minus 4 equals to 0. This is equation of the normal and this is equation of the tangent. 3x minus y minus 2 equals to 0. Okay. The previous two questions like these only. Next question. What about next question? It's the same. It's again same procedure. So fourth sub question there. Which curve you are given? Y equals to x squared. At which point you wanted origin 0 0. Just by observation also you can answer. In MCQs this would be helpful. What is this? This is parabola, if you remember. Symmetric about which axis? Y axis. So parabola will be like this, 11th standard. Which variable is free from square y? So it will be around y axis. This is origin. So can you see from the diagram what's the tangent here? Tangent is nothing but what here? X-axis. You can see tangent is simply here x-axis in the fourth sub question. And what's the equation of the x-axis? Y equals to 0. Fine. And what about normal? Here normal, how do you get the normal? So that is also obvious. Normal is a tangent at the point of contact. So what's the perpendicular to the x-axis at the point of contact? That's the y-axis. So this represents the normal. And what's the equation of the y-axis? That is x equals to 0. So this is equation of normal. You can do by procedure x as I explained. And this is nothing but what? Equation of tangent. Equation of tangent. Fine. How we'll do by method? Follow this. So you can do it. Okay. We'll go to next question. Here. Yes, you have parametric equations. We did it. So I think not difficult for you. X equals to cos t. Y equals to sin t. At which place? At t equals to pi by 4. So at t equals to pi by 4, x0, y0 will be cos pi by 4, 1 by root 2. Sin pi by 4, 1 by root 2. This is point of contact. Fine. And now you need the slope of the tangent. What is the slope of tangent? Dy by dx. You know it. Dy by dx. How do we get the dy by dx? Dy by dt, parametric equations, upon dx by dt. What is dy by dt? Dy by dt we know. It is nothing but the cos t. and here you have minus sin t. So this is minus cot t, and you put t equals to pi by 4, so minus 1, right? At which at t equals to pi by 4. Fine. So it would be just minus 1. Okay, so what's the equation of tangent? Equation of the tangent here, y minus 1 by root 2 equals to slope minus 1 into x minus 1 by root 2. Just simplify, take LCM and simplify. Okay, and what's the equation of the normal here? Equation of normal, y minus, point will be same, point of contact, you know, but here reciprocal with opposite sign, which is 1. The product of these two should be minus 1, x minus 1 by root 2. Here this will get cancelled, so normal will be just y equals to x. Here you simplify, so you'll get the required equation of the tangent. This is very basic question. In the next question, you're asked to find the tangent parallel to this line. It means slope of tangent equals to slope of this line. What's the slope of this line? Minus a by b, minus 2 by minus 1. So it will be 2. Which concept you have used here? M1 equals to M2. Two lines are parallel if and only if their slopes are equal. In the last session also we have used this concept. But what is the slope of the tangent? You know it is dy by dx. Get the dy by dx from this. So what is that? It is 2x minus 2 equals to 2. Dividing by 2, so x minus 1 equals to 1. So x is 2 here. Now if x is 2, how do we get the y? Put x equals to 2 here. So we'll get the y from this. This is actually y0, this is x0. So from this you will get the point of contact x0 comma y0. Can you recall? In the last session you had such questions. You got this is point of contact, and then you can write the equation of tangent now. Equation of tangent. What is the equation of the tangent? As we have used number of times. Y minus y0 equals to slope. Slope you know from the beginning. What's the slope? It is 2 into x minus x0. x0 you are going to find from here, this one. You are going to put here, y0 you are going to put here, and simplify. Fine? Okay. Question number 2, second sub question there. In the second sub question here, tangent is perpendicular to this line. Okay, so here we use that m1 into m2 equals to minus 1 concept from 11th standard coordinate geometry, you know very well. There you have used m1 equals to m2. Here we use this. What is the slope of this line? Minus a by b, that's the formula. So minus 15 by 5, but one more minus sign is there, minus a by b. So this is 3. This is the slope of the given line. And therefore, what will be the slope of tangent? Slope of tangent will be what here? Slope of the tangent will be, you are going to use this concept. Which concept? m1 into m2 equals to minus 1. So reciprocal with opposite sign, minus 1 by 3. Fine. Now slope of the tangent, you know it is always dy by dx. So what is dy by dx? Minus 1 by 3. I hope this is clear to you. I have used this concept. There we had parallel, so we have used m1 equals to m2. So slope of this line represents slope of the tangent, which is dy by dx. Here slope of the tangent using this product of the slopes equals to minus 1. If the slope of this line is 3, then this is minus 1 by 3. Now you just put the value of dy by dx here, and from there you will get the x0. You need to get the point of contact here. So what is dy by dx? It is 2x minus 2. 2x minus 2 equals to minus 1 upon 3. So let me simplify here. 6x minus 6 equals to minus 1. So x will be here 5 by 6, which is indirectly x0 in our language, point of contact. How do we get y0? Put x equals to x0, that is 5 by 6 in the function. So as, what is the formula for function? Y equals to, you know, x squared minus 2x plus 7. put 5 by 6 here. So 5 by 6 the whole square minus 2 into 5 by 6 plus 7. So you will get y0. And you just simplify this, you will get here y0. So you got the point of contact x0, y0, which is how much? This is 5 by 6. This you need to find. Just simplify and get it. Okay. And once you have this point of contact, you can write the equation of the tangent now. So equation of tangent, right? Equation of the tangent here, points law form, y minus y0, that you are going to find here and place here, equals to slope. What was the slope? You know, it was minus 1 upon 3. Slope of the tangent, remember. Into, look at it, one of the earlier lines, slope of the tangent, minus 1 upon 3. Okay. Into x minus x0. What is x0? You know, it is 5 by 6. Now the question is, you just simplify, so you will get the required tangent here. In the next question, you want to show that for this curve, tangents at 2 at x equals to 2 and at x equals to minus 2 are parallel. So what we do, we find the slope of the tangent at 2, slope of the tangent minus 2, and we'll see that both the slopes are equal because tangents are lines. So the slopes are equal, then they must be parallel. So you need dy by dx, because for the slope of the tangent you need dy by dx. What is dy by dx? 21x square plus 11. You have square, so minus 2 plus 2 is not important. So therefore dy by dx at 2, that is equals to 21 into 4 plus 11. So it would be here 4 plus 11. So, oh sorry, this will be 0 because this is a constant, I'm sorry. So 11 won't be there. So this is just, 4 and 8, 84. This is just 84. And same thing here, dy by dx at minus 2. So what we'll get from this? It will be 21 into minus 2 whole square. So again it would be 84, right? So slopes of tangents are equal, and therefore tangents are parallel. That's conclusion. Tangents are parallel. Fine. You have used which concept? Again, coordinate geometry, 11th standard. M1 equals to M2. Slopes are equal if and only if corresponding lines are parallel. This was my mistake little bit. 11 being constant, derivative is 0. So just 21x square. We have placed 2 and minus 2 and we have noticed that the slopes are equal. That much only. Very, very basic question. So in the next question, you are given this curve. You are asked to find a point. So let point be x0 comma y0. You want this point. This is a question. Such that the tangent, slope of the tangent is nothing but the y coordinate of that point. That means dy by dx, that's the slope of the tangent, equals to y coordinate of that point, that is y0, that is given to you, and we are asked to find this. This is a question. Get this. Okay, so what is dy by dx? You know, this is a slope of tangent. Number of times we have used this. Dy by dx represents the slope of the tangent. What is dy by dx? Here it is 3x squared. 3x squared equals to, you have y0, but dy by dx at that point. So instead of x, you are going to put x0. So we have here 3 x0 squared equals to y0. 1 is this. I hope this is clear to you. Slope of the tangent at that point. So here x equals to x0. So whenever you differentiate it, in place of x you put x0. And right hand side you are already given. This is given in the question itself. That slope of the tangent equals to y coordinate of that point. Okay. Now, one more relation you need to get. How do we get it? Can you recall? If you just recall, this x0, y0 is always on the point. point is always on the curve, so it must satisfy the given equation. So you have y0 equals to x0 whole cube, right? If you want, just you can write x0 y0. Point is always on the curve, is on the curve, belongs to the curve, so it must satisfy the equation of the curve. So now you have two equations about x0 y0. So just solving these two, solving 1 and 2, you get the required point. Okay, so how do we solve these two? Put the value of y0 there. So 3x0 squared, y0 are equals to x0 cube. So you can find x0 square common. So here 3 minus x0 equals to 0. So either x0 square equals to 0, that is either this is 0 or x0 equals to 3. So we have these two things. If x0 equals to 0, how do you get the y0? You can put again in the equation of the curve. So y0 equals to 0, putting here in the curve. And if x0 equals to 3, what is y0? That is nothing but put here 3 cube, which is 27. So that means there are two possibilities. So points are this, one is origin or the other one is 3, 27. 3, 27 and 0, 0. Okay. Next question is, you are given a curve, find all points at which the tangent passes through origin. The question is here, you are given a curve. What's the question here? Find all the points. You are asked to find the points for which the tangent passes through origin. So the question is like this here. Suppose you have one curve like this. You get this point, indirectly point of contact, in such a way that this tangent must pass through the origin. This must pass through the origin like this. So this is one tangent. You may have other tangent here. So one more tangent should also pass through this. Getting me? So here x0, y0 need not be a point of contact. Understood? You are simply given that tangent passes through the origin. You get such point of contact. So you want this, you want this. For which if I draw the tangent, it must pass through origin. If I draw the tangent here, it must pass through the origin. So origin is not the point of contact, remember. Keep in your mind. Okay, don't have misinterpretation with that. Okay, so but before I get into the further things, I need slope of tangent. So let me find that. That is dy by dx. And what is that? 4 3s are 12x squared minus 10 into x raised to 4. Okay, now what we do in general, we take that point as, for example, here x0 comma y0. Let the point be x0 y0. We want this point of contact. It can be this, it can be this, or maybe a number of points, but let point be this. We are asked to find this. We'll find this. Okay, now at this place, so slope of the tangent at dy by dx here. So dy by dx at x0 y0. That means in this function, wherever you put x0 minus 10 into x0 whole raised to 4. Fine, we call this as 1. Now, as we did earlier, this point is always on the curve, so it will satisfy the equation of the curve. Also, x0 y0 lies on the curve. You know it, we already used the same concept. Fine. Okay, so it will satisfy the equation of the curve. So you will get the y0 equals to 4x0 whole cube minus 2 into x0 whole raised to 5. Okay, call this as 2. Now equation of tangent here. Equation of tangent. From where tangent passes? Origin. So here y minus y0, but y is 0 here, minus y0 equals to slope. What's the slope of the tangent here? Slope of the tangent you already computed, which is 12x0 squared minus 10 into x0 raised to 4 into x minus x0. Why x and y are placed here 0? Just if you want, you can write tangent is through 0 0. So 0 0 must satisfy the equation. Is this clear to you? Y minus y0, but tangent passes through origin, so instead of variable y it becomes 0. This is simply slope into x. X is 0 here. So x minus x0, because 0 0 satisfy the equation of the tangent. Okay, so this minus sign and this minus sign will get cancelled. So y0 equals to, here you will get the 12x0 cube minus 10 into x0 raised to 5. Okay, this is third equation. So you got now two equations, equation 2 and equation 3. With help of these two equations, we get x0 and y0. So now that first one we already used here, remember. So from 2 and 3, we just compare them. y0, y0. So you have here 4x0 cube minus 2 into x0 5 equals to 12x0 cube minus 10x0 raised to 5. 4x cube I'll take on the other side. So 8x0 cube. 10 I'll take over here. So it will be 8x0 raised to 5. So 8 will get cancelled here. You can take x0 cube common, so you will get x0 squared. If you take this one on this side, minus 1 equals to 0. Okay. That means you have here three possibility, either x0 equals to 0 or x0 whole square minus 1 equals to 0. That means this is equal to 0 or x0 equals to plus or minus 1. So 0 or x0 equals to 1 or x0 equals to minus 1. If you have x0, you can find y0s from number of equations. You can use, for example, these or this. Suppose I am using 2 curve. So put x0 equals to 0 here. So y0 will be obviously 0. So 1 is this. Or put x0 equals to 1. I'm putting x0 equals to 1. If I put x0 equals to 1 here, then what will get from this? Here 4 minus 2, so it will be just 2. And here, if x0 is minus 1, what is y0? So this is minus 1 and this is plus 2, so you are left with minus 2. Fine. So the required points are, these are the 3 points. One is 0 0. The other one is 1, 2, and one more is minus 1, minus 2. At these 3 points on the curve, tangent passes through the origin. This and this itself become point of contact. Right? But this need not be point of contact. This need not, 0 0 need not be here point of contact. So you have one tangent at origin that passes through itself, then tangent at 1, 2 and minus 1, minus 2. It's a really good question. Okay. I just again recap this solution. Only important points are these two. One is slope of the tangent here at x0, y0. Point is always on the curve, so it satisfies the equation of the curve. This is very important step even in MCQs also. If you are given point of contact, then it will be always on the curve, so use this. I just wrote the equation of the tangent and then we have solved this too, nothing. Okay, let's go to next question. Find the points on this curve. You are given one curve here in 19th question. The curve is this. This is implicit function. X squared plus y squared minus 2x minus 3 equals to 0. This is a given curve. Implicit function. You need to recall the differentiation. Okay. At which tangents are parallel to x-axis. at which tangents are parallel to x-axis. So immediately you must have what in your mind? What's the slope of the tangent? What's the slope of the tangent? That is same as the slope of the x-axis, which is 0. So you are going to compare dy by dx with 0. Finished. That's all in all about the solution. I'll just help you to get the dy by dx, which is the slope of the tangent. So differentiating with respect to x. Okay, what's the derivative of x square? 2x. What's the derivative of y square? 2y into dy by dx minus 2 into here 1, 3 being constant, 0. You can divide by 2. So x plus y into dy by dx minus 2 equals to 0. So get the dy by dx. What is dy by dx here? Dividing by 2. So this will be 1. So this is 1 minus x by 2. Right? You have this. Fine. Now you want point of contact here. So now as you are given slope of the tangent equals to 0. Why? Because here you are given that the tangent is parallel to x-axis. And what is the slope of the x-axis? Always 0. Here slope is 0. You know very well. So slope of the tangent should be 0. That means dy by dx should be 0. But usually at x0, y0. So 1 minus x0 upon y0. Slope of the tangent at x0, y0. They are placed here x0, placed y0 equals to 0. This will go that side. So 1 minus x0 equals to 0. So x0 equals to 1. Fine. You can keep x only. Doesn't make a difference. Normally for point of contact we use x0, y0. That's why I'm emphasizing. Now, how do we get the y0? So for that you need to put x0 where? Point of contact is always on the curve. So where you are going to put this x0 equals to 1 in the given function. Right? So I'll call this as just 1. Put x0 equals to 1 in equation 1. In equation 1 means what? On the curve. Point of contact is always on the curve, remember. So you got this x coordinate. Now how do you get the y coordinate? Putting this into the function. So you will get, I think, because of quadratic equation, 2 values of y or y0. Because you have squared there. And therefore, you will get the 2 points. One is here, your final answer is 1, 1 you are going to find from here, and the other one is 1, 1 more you are going to find from here. That much you can do. Calculation wise, not a big task. You need to put x0 equals to 1 in the function. What I did in the beginning, the important concept I've used, tangent is parallel to x-axis. Slope of the tangent is 0. What is the slope of the tangent? dy by dx. Normally we take the point of contact at x0, y0. So x0, y0 equals to 0. Got x0? I place there. Fine. Now let's go to next question. Question number 20. Find the equation of the normal at the point. So this become point of contact. So here this is given to you. So question become very simple once your point of contact. Curve is given. So what you need to get? You need to get the slope of normal. Slope of normal. What's the slope of normal? We know. It is minus 1 upon dy by dx at that place. At x equals to x0. So get the dy by dx at this point. Take the reciprocal with opposite sign. You have normal. You have the point, so you'll get the equation of the normal. Okay, so I'll differentiate this as you have ay squared equals to x cubed. Differentiating a, what's the derivative? A being constant as it is, derivative of y squared. 2y into dy by dx equals to 3x squared. Fine. Is this correct? A being constant as it is. What's the derivative of y squared? By chain rule 2y dy by dx. You know very well. This is just 3x squared. So what is dy by dx? So here dy by dx will be 3x squared upon 2ay. and dy by dx at which place? At x equals to at x0 y0, at x0 comma y0. So which is equals to, instead of x0 you put am square, so 3 into, instead of x, am square, so a square m raised to 4 upon 2a, instead of y you put a m cube. So 3 as it is, 2 as it is, a square will get cancelled, you are just left with m. 3 by 2 m. Is it? And therefore slope of normal, that's reciprocal with opposite sign here, minus 2 by 3m. Reciprocal with opposite sign. Which concept you have used? m1 into m2 equals to minus 1. Right? Already explained in the theory. Now equation of the normal. So equation of normal here, you know, point slope form, y minus y0. What is y0? That is am cube equals to slope. What is the slope here? Minus 2 by 3m into x minus x0. What is x0? That is am square. Now the question is, you just simplify. Right? I leave it for you. You need to simplify. That's a required normal. Take these over here and write in ax plus by plus c form. Fine? Question number 21. I'll not do it. You just refer question number 5, 6 and today's session first question 14. Right? See this. Try it. Not a big task. Very basic question. 22. You are asked for equations of the tangents and normals to this curve. Which curve? Again, like question number 14. Y square equals to 4ax. Point of contact you are given. At which place? 80 square comma 280. Fine? At this place. So like as per our standard notation, this is like x0 and this is like y0. You need differentiation here, dy by dx. This is by chain rule, 2y into dy by dx equals to 4a being constant as it is. Derivative of x with respect to x is what? 1 here. I repeat, what is derivative of y square? It is 2y dy by dx equals to 4a. So what is dy by dx here? It would be 4a by 2y. So it will be 2a by y here. 2a by y. That is nothing but the slope of the tangent. But here, of course, you need to place this. So let me write here slope of tangent, that is equals to dy by dx at a given point x0 comma y0. So instead of x you are going to put this, instead of y you are going to put this. So 2a upon 2at. So we'll get just 1 upon t. We'll get what? 1 upon t here. T should be not base 0. Okay. So I'll write the equation of the tangent. Equation of tangent. Now you have slope and you have point of contact. So y minus y0. What is y0? You know, it is 2at equals to slope 1 by t into x minus x0, which is at square. So let me just rewrite this here. So you will get the yt minus 2at square equals to x minus at square. I'll just write in ax plus by plus c form. Just taking this side. Now x minus yt and this expression over there. This is 2at square. This is just at square. So it will be plus at square equals to 0. This is equation of tangent. How do we get the equation of the normal here? So equation of the normal, y minus y0, same thing, 2at. Slope will be different here, reciprocal with opposite sign, which is minus t, x minus at square. Point of contact is same here, right? You have used m1 into m2 equals to minus 1. What's the slope of the tangent? 1 upon t. So reciprocal with opposite sign for normal. Now let's simplify. So minus 2at equals to minus tx plus a t cube. So tx here plus y. I'll keep this minus 280 as it is, minus 80 cube equals to 0. This is the required equation of the normal. Tx plus y minus 280 minus 80 cube. Fine, that's required normal. So we are given two curves and we are asked to show that they intersect a right angle with this. So we use k squared equals to 1 by 8. Now question is, what do you mean by the intersected right angle? So we use the concept of the slope of the two tangents at the intersection point. Suppose one function is like this, the other function is like this. We say that they intersect at right angle if the tangents are perpendicular. So one tangent over here to the first curve and the other tangent over here. This is the tangent to the second curve. This is the second curve here. So if at the intersection point two tangents to two curves are perpendicular to each other, then we say that the two curves intersect at right angle. This is a theory actually, but which is not given in our textbook, so I have not discussed. But let me tell you here what it says. What do you mean by two tangents intersected two curves intersected right angle? It means draw the tangents at their point of intersection and show that the tangents are perpendicular to each other. Now how do we show that the tangents are perpendicular to each other? So get the slope of this tangent, get the slope of this tangent, and you show that their product equals to minus 1. So what we need to show here? We'll show that the products of the slopes of two tangents equals to minus 1 at the intersection point. Okay, so that usually we take as point of contact, so x0 comma y0. So let intersection point equals to, you can do directly also, intersection point be this x0 y0. So we can get this by solving these two equations. So solving the equations here, we solve the equations. So we'll get this point x0 y0. How do we solve this? Just put the value of x here. So y square, this y is already there, equals to k. So y cube equals to k. So it implies y equals to k raised to 1 by 3. Okay, so this is indirectly y0. And now put y equals to k cube here. So we'll get the x. So you have k raised to 1 by 3, the whole square, that is k raised to 2 by 3. So you got the common point, intersection point, that is x0 y0, which is equals to k raised to 2 by 3 comma k raised to 1 by 3. Fine. Now what we do, we get the dy by dx for the first curve, dy by dx for the second curve, and at the intersection point we'll show that the product of the dy by dx equals to minus 1. Fine. Okay, so now for this curve x equals to y square, let's differentiate it. 1 equals to 2y into dy by dx. So it implies, what is dy by dx here? For the first curve, that is equals to 1 upon 2y. That's for first curve. For the other curve, you can write y equals to k by x, taking x down. So what is dy by dx here? K being constant as it is, derivative of 1 by x is minus 1 by x square. Okay. Now at intersection point, we'll show that. So now product of slopes of tangents at this point, k raised to 2 by 3 comma k raised to 1 by 3 equals to, here 1 upon 2y into minus k by x square. just we place the value. So 1 upon 2 into y. What is y here? This much, intersection point. So k raised to 1 by 3 minus k as it is. Here you squared this. So this is k raised to 4 by 3. Fine? So here minus 1 by 2 as it is. This is k right now as it is. Here if I add the powers, this is k raised to 1 by 3 plus 4 by 3. It will be k raised to 5 by 3. Okay, here power is 1. So let me simplify further. Here minus 1 by 2 as it is. Here this is, if I add both the powers, you will get the finally k raised to 2 by 3. Just think, both the powers get subtracted. Now you have information about square, so I can write k squared the whole raised to 1 by 3. You know, meaning of this 2 by 3 is this indirectly. But what is k squared? Just look at it given data. K squared is 1 upon 8 raised to 1 by 3. See, 8k squared is 1. So what is k squared? Is 1 by 8. This is 2. 1 upon 1 by 2. So this will get cancelled. So we'll get the minus 1. Right? So what you have proved? Look at it, previous page. Product of the slopes at the intersection point equals to minus 1. Right? And therefore, what's the conclusion? Therefore, two curves intersect at right angle. Right? That's your conclusion. So curves intersect at right angle. Intersect at right angle. If we have this 8k square equals to 1, you have just shown that product of the slopes at the intersection point equals to minus 1. You have used indirectly this concept, m1 into m2 equals to minus 1. But where? At the intersection point. At the intersection point of what? Tangents. Right? You have used the concept of the tangent indirectly. Fine. Now, what about next question, 24? Find the equations of the tangent and normal to this hyperbola at x0, y0. Okay, you want both. So this is like question number 14 only. This is just copy of question number 14 only. There you did both tangents and normal. Here you are given the standard hyperbola. So I'll not do the entire solution. I'll just tell you the beginning what to do. Here in 24th, the curve is this. Which curve? Hyperbola x squared by a squared minus y squared by b squared equals to 1. And point of contact is this x0, y0. Your final answer will be in this form. You need to differentiate this to get the slope of the tangent. Once you get the slope of the tangent, you have points, you can get the equation. So to get the equation, we need to differentiate this. So differentiating, this is constant, 2x by a square, b square being constant with the function as it is 2y into dy by dx, derivative of 1, 0. Right. Simply differentiation. What is derivative here? Derivative, that is a square. Do not use division rule here. Please don't use division rule because the denominator is constant. Fine. So simply differentiation of x square, that is 2x a square as it is. You know now number of times we did it. So get the dy by dx. 2 will get cancelled. Take one term on the other side. So x by a square equals to y by b square into dy by dx. So therefore, what is dy by dx from this? You will get here, this y will come down. So x by y and b square will go up. So b squared by a square. Fine. Now slope of the tangent at x0, y0. So here I'll write slope of tangent equals to b square by a square into instead of x, x0 upon instead of y, y0. What's the slope of the normal? Do reciprocal with minus sign. That's the slope of the normal. That is minus a square y0 upon b square x0. Fine. This is the tangent with the slope. Okay. Now we write the equation of the tangent. So here equation of tangent, it will be y minus y0 equals to slope. What's the slope? You did it. B squared by a squared into x0 by y0 into x minus x0. I've used simply point slope form. Now let's simplify this. You cannot live in this form. So I'll take y0 a square over here. So y0 a square into y minus a square y0 square equals to, if I open the bracket here, b square x0 x minus b square x0 square. Fine. This is x term, this is y term. So I'll just rearrange here. How to rearrange? Let me take this one over there, y term, and this one over here. So b square, I'm taking this term on the left side. B square x0 square minus a square y0 square. I'll take this one over there. B square x0 into x minus a square y0 into y. Now you can see, you can divide by here. Dividing by, I think, dividing by what? A square b square y, you will realize. So this is x0 square upon a square minus y0 square by b square equals to, this is x0x by a square minus y0 into y upon b square. That a square will get cancelled. You are dividing by this. One a square will get cancelled. Here b square will get cancelled. So you are left with a square. Your b square will get cancelled. A square. Here a square will get cancelled. B square. What is this? This is known to you. Can you tell me? What is this? This will be 1. Why? Why it is 1? Can you think why it is 1? In fact, to show this, I did the entire solution. This is the required equation of tangent. Can you think why it is 1? Because x0, y0 is on the curve, so it must satisfy the equation of the hyperbola. This belongs to curve, so it satisfies the equation of the hyperbola. What's the equation of the hyperbola? This one. So in place of x, you have x0 by a squared minus, in place of y, you have y0 whole squared by b squared equals to 1. And this one I have used here, this I have used here. Right? So this is required tangent. Now how do we get the normal? I'll not do it. Equation of the normal would be same. Y minus y0, here slope into x minus x0. How do we get the slope of the normal? Reciprocal with opposite sign. So minus a square y0 upon what we'll get here, b square x0, and then now simplify further. This is just the reciprocal of the slope with minus sign. Which concept? m1 into m2 equals to minus 1 minus a square y0 reciprocal with opposite sign. You have used, you know now, number of times already explained. M1 into m2 equals to minus 1. Simplify, so we'll get the required equation of the normal. 25th, find the equation of the tangent to this curve, okay, which is parallel to given line. Okay, so your line is this, parallel to this line, 4x minus 2y plus y equals to 0. Tangent is parallel to this line. That means the slope of tangent equals to slope of this line minus a by b minus 4 by 2, which is just 2. What's the slope of the tangent? dy by dx equals to 2. Get the dy by dx. So from this you will get probably x or y. Once you get x, put over here. So this is y. This is indirectly x0 and y0. So we'll get the point of contact. And then use this y minus y0 equals to slope. Slope you know from the beginning, which is 2 into x minus x0, right? That much only. We did it number of times earlier. Still, if you want the reference, just refer this question number 15, first one. See the first one, copy of that. Even question number 13 also, right? I already explained the flow of the solution, but still if you want, you can refer this too. The next question, which is an MCQ, solve the slope of the normal to this curve. Okay, at x0, that's given to you. So you need the slope of the normal, that means dy by dx. So we have here 4x, 3 being constant as it is, this is cos x. So slope of normal, that is, minus 1 upon dy by dx, that is 4x plus 3 cosine x. At which place? At x equals to 0. So put x equals to 0 here. This is 4 into 0. This is 3, cosine 0 is 1. Put x equals to 0, cos 0 is 1. So you will get the minus 1 upon 3, which is nothing but the option D here. In the next question, you are given curve with the tangent. Tangent, equation of the tangent you are given, y equals to x plus 1. What is asked? The point, that is point of contact you are asked. So how will do this? Just get the slope of the tangent from this and the slope of the tangent from this. What's the slope from this? You compare with y equals to mx plus c, or you can use minus a by b formula, whichever way you do. Slope will be 1 here. Slope of the tangent, small m. This is slope. And how do we get the slope from the curve? Just by differentiating. So I'll differentiate it. 2y into dy by dx equals to 4. So dy by dx would be here. You will get the 2 by y. This is the slope of the tangent. This is also slope of the tangent. So we just compare these two. 2 by y equals to 1. So y equals to 2. And once you get the one coordinate, the second coordinate you can find from the equation of the curve. So put y equals to 2 there. So we'll get the 4 equals to here 4x. So it implies x is 1 here. So x comma y, which is 1 comma 2, which is nothing but the option A here.